being beside each other, it's amazing. They actually satisfy the 8 electrons, causing it to be an insulator. So what they do to cause this to conduct electrons is they dope it. They call it doping by introducing a contaminant into the material, either, for example, phosphorus or boron. A phosphorus atom has an extra electron around it, and when they put it beside the silicon atom, it now has 9. So it's got an extra one here, and that extra one is what allows it to be knocked free and moved along to conduct electricity. When you put a boron, for example, contaminate it. By the way, this is called a copy my drawings I drew earlier. This is with boron, it has 1 less electron. So it creates what we call a hole. So when it's lined up with all the other silicon atoms, that hole allows the drawing of an electron into it. And that's a p-type dopant. And with phosphorus it would be an n-type dopant. So that's about as technical as I'm going to get. The rest of the, actually, let me show you what an electron looks like. Oh, that's a little too fast. Okay, awesome. So we have a silicon atom, and on the outer shell is where the valence electrons, they circle around it, and there's 4 in a silicon, but again 8 will be around there when it's sitting beside in the crystal lattice. What can we do with this? Well, this is where things start getting interesting. Sorry guys, this thing will get started. I'll catch my stride. So what can we do with these things? Well, we can create what's called actually, no, I'm not going to move it. A PN junction. Let's draw this out here. So what we do is we'll take some of the P material that's, did you get through it, Jason? Some of the P material, and we wedge it together with some N material. The N material, again, is mostly negative because it's been doped by phosphorus, so it has an extra electron. The P material has less electrons, so it has holes in it. So these two things will attract each other. What happens is, without connecting to a circuit at all, right in the middle where it's joined, it creates what we call a depletion zone. The extra electrons near the joint are attracted to the holes on the positive side. So some of the electrons in this area will go over here to satisfy the 8 slots on the P material. This actually instantaneously happens when they're joined, and it creates a small voltage. And silicon diode, if you were to measure the voltage right here, it's about 0.7 volts. So that is useful how? Well, what this will allow us to do is this is going to allow us to control the flow of electrons in one direction if you connect to a circuit. So if I was to connect one end, by the way, the N side, the connector is called a cathode. On the P side, the connector is called an anode. So I'm going to connect this to a battery. This is the negative side, positive side. Normally you wouldn't do this without some sort of load in here because it's going to draw too much current. But for simplicity's sake, what happens now is, because right here where this depletion zone is, where these